Hello, everyone. My name is Duffie Cooley, and I'm the field CTO at Isovalent, where I work with Cilium and eBPF every day. I'm here to talk to you about networking, security, and observability. Let's jump in. First, a little bit about Isovalent. We were founded a little over 5 years ago by Thomas Graff and Dan Wentland. Dan and I first met at Nicira, where we worked to define the network virtualization space for our industry. Thomas has spent his career working on Linux, the Linux kernel, and also bringing eBPF forward, both in the Linux kernel and also in the ecosystem at large. We are a remote first team with offices in Switzerland and the US. Cilium is the leading CNI in the Kubernetes ecosystem today. We are seeing just an incredible amount of adoption out there, and it's really a pretty exciting time. And in this presentation, I'm hoping that you could leave this presentation understanding a little bit more about why that is. It is an open source project that's focused on networking, security, and observability. eBPF is the technology that we employ to bring all of this to reality. We develop eBPF in the Linux kernel and develop Cilium to make use of those features that we're extending in the Linux kernel. Isovalent is the company behind Cilium, and as part of our offering, we provide an enterprise solution that extends the Cilium open source project to satisfy a lot of really interesting enterprise security use cases. You've heard me say eBPF a lot. Let's jump into what it is. So eBPF, you've probably heard it described as superpowers for your systems. It's tooling that allows you to attach business logic to pretty much anything running inside of your kernel, from what happens when a file gets opened to when a socket is created for an application to communicate with some other application. We can hook into pretty much any part of that, including being able to interact with connections even at the connect layer before the TCP/IP stack gets involved. So really pretty early in the process of opening a connection between applications, we can actually make decisions right there whether to allow or deny that traffic before it even hits the TCP/IP stack. Because Cilium has the ability to tie into pretty much any subsystem within the Linux kernel, this really opens up a lot of really interesting areas around security, tracing and profiling, networking and observability, and all in a way that is safe and efficient for your kernel. There is a lot you can do with BPF, but BPF is actually we have verifiers in place to ensure that you can only write BPF programs that are safe. Here's a snapshot of the BPF landscape and kind of how I think about BPF in the ecosystem today. We break this across a variety of different categories, but generally they fall into networking, security, observability, and tracing. And this is broken up into different user space areas, right? We can actually, one of the incredible things about BPF is the rich metadata, the context that we can actually gather about what's happening about applications that are interacting with the Linux kernel. We can do things like auto instrument the functions of an application. This is where projects like Pixie come in. We can do things like emit events when traffic happens. And you're going to see more of that from me about Cilium here in just a little while as we get into the Cilium part of the conversation. We see a number of really great projects out there like the BCC and kubectl trace, tools that allow us to really kind of dig in and understand actually what's happening with our application. What is the application spending its CPU time on? What types of packets has it sent? What sorts of connections are we seeing coming in through network interfaces and all of that? We're going to get into some demonstrations on that in just a little while. The user space is also a thriving ecosystem. We see libraries and SDKs for pretty much every usable language out there, including things like Rust, Go, C, just tons of really great stuff. And these libraries are broken across a variety of different interest areas as well, from tracing to profiling to monitoring. And finally, we have the kernel interface itself. So as you write these programs, They have to be compiled into eBPF programs that will be injected directly into the Linux kernel runtime. And before that happens, it has to pass through a verifier and be just in time compiled. Maps are how we actually get some of that rich context we're gathering, not only out of the Linux kernel user space and down into user space so that applications like Cilium and Falco and others can make use of it. And it's pretty exciting stuff. It's so exciting, in fact, that even Microsoft is involved now. So we're looking to see things like eBPF happen in Windows environments as well. If you'd like to learn more about eBPF, check out the eBPF Foundation. We recently co-founded this with Facebook, Google, Microsoft, and Netflix. And if you'd like to learn more about it, you can check us out at ebpf.io. That website will also show you links to past and future eBPF Summit presentations, giving you a deep dive into all of the different ways that eBPF is useful to large companies today, and to small companies as well, and resources for learning about all there is to know about eBPF. Now let's jump in and talk about Cilium a little bit, and then we're going to get into the action part of our talk. I'm looking forward to that myself. So Cilium is a CNI. It is a container networking implementation. It is the way that your pods communicate with each other inside of your Kubernetes cluster. We can, as part of our CNI offering, replace kubeproxy and handle all of that Kubernetes service handling, from Kubernetes services type load balancer, Kubernetes services type cluster IP. All of those things we can actually handle without the need for kubeproxy. And this actually allows you to deploy Cilium in a way that removes quite a lot of the churn of IP tables from your ecosystem, from your environment. We can also, leveraging Cilium and cluster mesh, give you the ability to allow pods to communicate directly across clusters, turning multiple Kubernetes clusters into one flat pod networking fat pod networking space, so that pods can communicate, and you can also extend services that are shared across clusters. From the networking security perspective, we actually do satisfy things like the Kubernetes network policy, but we also provide a superset of network policy that allows us to do things like FQDN policy, dropping traffic that is destined for a given FQDN rather than by IP address, which makes your life a lot simpler when defining those network policies. We offer encryption to move back and forth between traffic, moving back and forth between nodes inside of a single cluster or across multiple clusters. We can encrypt that traffic with IPsec or WireGuard. From the observability perspective, we actually expose a lot of really interesting metrics about traffic. We're able to expose things like the TCP golden metrics, HTTP golden metrics, UDP traffic metrics as well. Just really kind of help you dig in and understand what's actually happening with that traffic inside of your cluster. And we're going to see some examples of that here in just a little while. We also provide flow visibility, so you can see that connection between things, and you can actually see that in a service graph that we're going to demonstrate. If you want to get started with Cilium, if you want to play with it, you can actually download it directly from the operator from the operator catalog within your OpenShift cluster. And we have a lot of really great getting started guides at cilium.io, both on OpenShift, OKD, standalone Kubernetes that you deploy with something like kubeadm, Rancher Kubernetes Engine, EKS, AKS, and GKE. Cilium install is flexible for all clouds and on-prem. And it's flexible, and by flexible, I mean we have different levels of integration with EKS. So for example, like we can actually deploy inside of an EKS cluster and handle the ENI handling for you directly without the need for the EKS ENI, the CNI. Google and AWS have chosen Cilium as the default CNI for Google Kubernetes Engine and for Anthos and for EKS Anywhere for all new clusters. Cilium integrates it with different clouds in a lot of really great ways. So if you're interested in exploring it, come check us out, cilium.io. Because of all of this, we've just seen an incredible amount of adoption from very large companies across a very wide array of of different verticals. If you'd like to see your name up here, come check us out at cilium.io. Now, let's go play with this stuff and see how it all works. So like I said, you can actually find us in the Red Hat ecosystem catalog. So if you're looking at the OpenShift operators, you'll find Cilium there. You'll also find Cilium Enterprise, but if you'd like to play with that one, come check us out and have a conversation with us. Now, I've gone ahead and stood up an OpenShift 4.9 cluster, and we're going to kind of explore it here. And I'm actually using Cilium as the CNI. So let's go ahead and take a look and see how that actually works here. So I'm going to take a look at pods. I'm going to look in the OpenShift namespace. Let's take a look at the actual console. So these are the pods that are actually backing the UI that we're looking at here, right? So when we actually look at the OpenShift UI, there is actually some console applications on the back end that are serving these things. Let's go ahead and take a look at some of them. So here is a YAML for one of the console pods that's running, and we can see right here in the YAML, as annotated by the network status, that this is actually running on top of Cilium. It's got a Cilium IP address, and that we are actually allowing that traffic to move back and forth inside of here. So pretty cool stuff. It's all coming in through an OpenShift route. It's terminating onto these pods using the normal mechanisms that OpenShift has built in. Now, I've also deployed another project called tenant jobs, and we're going to spend a good amount of our time in tenant jobs, like looking at those things. But let's jump into the, I'm sure there was an easier way to do that. Let's just go ahead and go up to projects, tenant jobs. There we go. So these are the workloads that are happening inside of the tenant jobs namespace. I've got a whole demonstration application. We can see the CPU, the memory, the network transfer rate for all of these things operating. We can see how many pods are running. There are 10 pods. We can see 7 deployments, 1 stateful set, lots of really interesting things in our example application. But what this doesn't really show us is how things intercommunicate. It doesn't show us a service map for how these things work. And although these metrics are very interesting, there's actually more that we could learn from this application with just a little bit more work. So let's go ahead and take a look and see what we can see at that level. I'm going to take you over to the Hubble UI. And this Hubble UI is actually the tooling that we use to visualize traffic within your Kubernetes environment, regardless of where it's been deployed. So we can see all of the namespaces for all of the traffic, or for all of the different projects deployed inside of this OpenShift cluster. And if we take a look into one of them, like the OpenShift DNS namespace, we can actually see traffic moving back and forth. We can see a service graph of everything interacting with DNS at this time. And as we watch it, we're going to see dynamically that things come and go and interact with DNS. Right? So these are the actual DNS pods. These are calls making UDP connections to these things directly. Let's take a look at our console, for example. So here we see connections going to the world. We see connections coming from the console. We see interaction between Thanos. And we see interaction between the alert manager. Lots of really interesting stuff happening there, right? So we can see a service graph that really shows us quite a lot of really good information. So let's jump back into our tenant jobs namespace and take a look at what's happening here. Inside of our tenant jobs namespace, we have deployed our sample application, and it gives us a view of what's actually happening within the cluster. So this application is actually just a tool that interacts with api.twitter.com, and it makes use of it. It scrapes it, grabs some information from that API, and throws it into kind of a machine learning sort of scenario here. When it all works out, we're looking for new employees all the time, and this is kind of like where this is coming from. So this tooling because of our network policies, we can actually see all of the DNS queries moving back and forth between these things. So we can actually see that this query from crawler.com, from the crawler, is going to api.twitter.com. If I jump over to a CLI here real quick, and I do a curl to google.com, or let's say google.com. There went a query. If I jump back over to my UI, you can see that new query showed up, right? So there is our google.com query, and we can see that traffic made it through. Now I've updated the policy to actually drop this traffic. Let's take a look at that. So as part of our network, as part of our offering here, we also have this tab over here called Network Policies. And the policy that I just added was this policy here. And this is an FQDN-based policy that allows traffic to api.twitter.com on port 443 and port 80, but it doesn't allow traffic on anything else. And because of the way that network policy applies, now that that's applied, we're not going to be able to see traffic to google.com anymore. Let's go ahead and try again and show that that actually works the way we expect. Oh, I wanted to go back to our service map. Let's load up our service map here. So there is all the connectivity. Let's go ahead and see if we can generate some drop traffic based on what we were just noticing before. Let's try again to google.com, and we can see that traffic is not going anywhere. It looks like it's kind of stale there. We can see google.com, and we can see our drops, right? We can see that traffic being dropped, and we can see what the reason is, right? Only allowing api.twitter.com, not allowing anything else. So it's easy for us to actually see the policy that is dropping our traffic, and it's easy also for us to add a new rule to that specific policy that's allowing that that's disallowing that traffic, to extend that rule, to extend that policy to include this new rule. So if I wanted to change this to include Google at 443, I would also be able to see that. Now we've talked a little bit about observability. We've talked a little bit about security. I want to show you a little bit more about observability that I think might be relevant to some of the operational folks that are attending this talk. Let's take a look at that real quick. So I'm going to take a look at all DNS queries across anything that I'm actually watching inside of Kubernetes. So these are all of the DNS queries that are happening within the cluster. And this is actually not just scoped to the namespace, although I've only got DNS visibility turned on within that namespace. I'd be able to see any DNS query that's happening to the DNS server if I made this a cluster-wide policy. If I wanted to see traffic that was dropped, I can actually look by verdict. There we see our traffic drops, right? We see Google at 443 policy being denied, so traffic drop. If I wanted to see by FQDN, these are questions that I can ask about any application within the entire cluster. This view is a view of all traffic moving through the entire cluster. And so you can see how this could be used to help you troubleshoot what's actually happening. If we take a look at this event, we can actually see the namespace that's associated with the event. We can also see the name of the pod, the specific pod that made this request. what the source port was, what the destination port was. We can see all of this information for anything in any namespace. There's a DNS response for api.twitter.com, giving us a response for all of these IP addresses and associating it with tpopapi.com. This is a cache response, and that response will be given to anything that tries to make a request to api.twitter.com based on DNS proxy. A lot of really good visibility here. Now I'd like to get into another example. I want you to take a look at some Grafana dashboards. As part of our effort, we actually are able to show you all the traffic that's moving. We're also able to expose metrics that are related to this traffic. So here are some TCP metrics that are exposable for all traffic within the cluster based on a tracing policy that you've defined. And so these metrics are actually showing us things like standard or smooth round trip time, but for traffic coming from particular applications within our cluster. And we can see if the round trip time increased or degraded over time. We can also see things like per destination, right? So this is a top 99 percentile of smooth round trip time per destination. So you can see that this traffic was actually destined for api.twitter.com and how long it took to actually get there. We can see top 10 transmit bytes per pod, right? So here is a Minio S3 bucket that we're using to hold all of these events. And we can see that it's getting the most of the traffic inside of the cluster at 1 megasecond, accepting traffic right directly into that S3 bucket as fast as it can. Here's the top list. The top sender the top ingester is the Hubble timescape ingester, which is actually pulling events off of that bucket. Right. This is all information that we can expose as metrics, increasing the metrics, the visibility, and the understanding of what's actually happening within your cluster. We can break this down by namespace. We can break it down by pod. All of these metrics are available. Some of the other things that we can actually show are UDP metrics. So that's our TCP metrics. Here's our UDP metrics. All right, these are top 10 RX UDP sessions. So lots of folks basically making DNS queries. The top DNS query looks like console. Oddly enough. And then we can also show you things like network statistics or network interface metrics. And we're able to get this information again from BPF and gather this information down to a place where you can actually see it, right? So here we're actually showing you the throughput for every node in the cluster on every interface of the cluster. And we can see that most of the traffic is actually going to one LXC interface. That's probably the LXC interface associated with our S3 bucket on worker 02. So we can really give you just an incredible amount of insight into what's actually happening from a metrics perspective, and also from a flow perspective. The last thing I want to show you before we take off is one more thing inside of the UI here. Along with everything else, we're actually able to introspect what's actually happening at a process level. So with this tooling, I'm actually able to see all the processes running within a container. So if I pull up one of my crawler pods, I'll be able to actually see the processes running within that container and any connections or execs or anything else that has happened for that container during the life cycle of the pod. So here is my crawler application that's been deployed. And I can see things like the example here where I have a node server, I have a Node.js script that's running inside of that. That's the init process. It's running as PID1 inside of the container. But at some point, about 5 minutes after this container started up, somebody must have exploited it and created a net connection to notreverseshell.com. Now, because of that DNS visibility, we can actually see that traffic moving back and forth, right? We can see what the FQDN was. We can see what's actually happening at the connect level and also at the exec level within the cluster. So all of this visibility with Cilium and Hubble Enterprise. Really great stuff. I hope that was really helpful for you. I know I really enjoyed giving this presentation. I hope that if you're interested in learning more, you're going to come check us out, and we'll see you again soon. If you would like to follow up with us, you can check us out at isobl.com, cilium.io, eBPF.io, or come join us on Slack at slack.cilium.io. And I hope you have a great show. Thank you so much for joining, and I'll see you all next time.